Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts project at thunderbolts.info. What fills the vast space and the unimaginable distances separating celestial objects in the cosmos? Space is indeed a big place, but it's not a perfect void or vacuum. Today, this fact is acknowledged even by the NASA Space Agency, which states in an official report from 2014. Space may appear empty, a soundless vacuum, but it's not an absolute void. It flows with electric activity that is not visible to our eyes. The movement of electrically charged particles requires a medium, and that medium in space is plasma, or the so-called fourth state of matter. Plasma is commonly referred to as a gas whose constituent atoms have been split into electrons and ions, which move independently of each other. Well over 99% of the visible universe is composed of plasma, including the Earth's ionosphere, the Sun and all stars, and nearly all of the interplanetary, interstellar, and intergalactic medium. Electric currents flowing through plasma can be recognized through their distinct filamentary shape, as seen in the familiar novelty plasma ball. With extraordinary advances in space telescopes, we see today in unprecedented detail filamentary structures that pervade the visible universe at all scales. The appearances of these distinct structures have proved puzzling to astronomers far more often than not, as they defy the expected form and behaviors of hot gas in a vacuum. In part 2 of this 10-part presentation, we explore why filamentation throughout the cosmos is just one of 10 reasons why the universe is electric. Filaments in space. Let us begin by considering the examples of filaments that we see locally associated with celestial bodies in our own solar system. The most dramatic displays can surely be seen on our Sun. Of course, we see huge plasma filaments, sometimes 1 million kilometers or longer, that occasionally erupt or explode off of the Sun's surface. But one of countless unresolved problems in solar physics is the observation of giant, snake-like filaments reaching from the surface of the Sun to the dark cores of sunspots. For decades, scientists following the standard solar model have viewed the sunspot penumbra filaments as, quote, convection cells, or columns of hot gases transporting heat from the Sun's interior to its surface. But as physicist Wal Thornhill has observed, the filaments bear no resemblance to any known form of convection in a hot gas. Indeed, in our first ever Space News episode, we reported on the discovery of anomalously weak solar convection by scientists measuring the Sun's internal plasma motions. The electric universe theory proposes that the Sun is not powered by an internal thermonuclear reaction, but rather it receives its electrical energy from interstellar space, in which case the absence of convection is to be expected. The complex magnetic fields associated with the penumbra filaments are acknowledged by solar physicists, as seen in the text of the Astronomy Picture of the Day image seen on your screen. Here, magnetic field lines can be clearly followed outward from the sunspot to distant regions, a clear defiance of the expected behaviors of so-called convection cells. In a 2002 article on his website, Thornhill wrote on the mysterious nature of sunspots. It is crucially important to understand a sunspot because it is the only place on the Sun that gives a glimpse below the bright photosphere. And what do we see? It is cooler down there by thousands of degrees. That is not expected at all if the Sun is trying to rid itself of heat. The sunspot's center should be much hotter and brighter than its surroundings. In the electric universe, the penumbral filaments are electrical discharges in plasma, in the characteristic form of long, thin, rope-like structures. If the filaments are, quote, convecting gas, then one would expect the filament centers to be the hottest and brightest points. But instead, solar physicists were amazed to observe that the penumbral filaments have dark cores. In the electric universe, the Sun and all stars are positively charged anodes, and the Sun's electrical circuitry reaches across vast distances throughout the solar system. The electromagnetic connection of the Sun to planets, including the Earth, is now undeniable. In 2007, NASA scientists were amazed to discover dynamic, so-called magnetic flux ropes that constantly, quote, form and unravel in Earth's magnetosphere. And in 2017, scientists with NASA's Cassini mission were astonished to discover that these same, quote, magnetic ropes connect the Sun and the planet Saturn over the incredible distance of nearly 900 million miles. These so-called magnetic ropes are in fact electrical Birkeland currents, which are now known to power Earth's auroras. It's now more clear than ever that planets within the Sun's electrical domain are electrically charged bodies. On our own Earth, this fact is best demonstrated by the relatively recent discovery of powerful lightning that sometimes occurs above thunderstorms, reaching towards space. For decades, airline pilots had reported their observations of the stupendous lightning, though it wasn't until the early 1990s that institutional science finally recognized the phenomenon exists. More recently, scientists working with the ESA Swarm mission reported their discovery of, quote, supersonic plasma jets high up in our atmosphere. A phys.org report on the discovery stated, the theory that there are huge electric currents, powered by solar wind and guided through the ionosphere by Earth's magnetic field, was postulated more than a century ago by Norwegian scientist Christian Birkeland. While much is known about these current systems, recent observations have revealed that they are associated with large electrical fields. The spectacular filamentary discharges we see in our upper atmosphere may have analogs in other bodies in our solar system that scientists have yet to recognize. The most extreme example may be seen on the Jovian moon Io, which astronomers have characterized since 1979 as the most volcanically active body in the solar system. But as we've discussed many times on this series, the theory that the spectacular so-called plumes are a form of cryovolcanism has been falsified on numerous counts. Just one of many problems for planetary scientists is outlined on the official Wikipedia page on the Vashtar-Patera region of Io, which states that the over 300-kilometer high so-called volcanic plume displays, quote, an as-yet unexplained filamentary structure. However, this statement is factually incorrect. The filamentary structure was explained decades ago by plasma scientists who recognized that the, quote, plumes are high-energy electrical discharges. This theory was first proposed by the renowned astrophysicist Thomas Gold in 1979. Then in 1988, plasma scientist Dr. Anthony Peratt and co-author Alex Dessler explained in a peer-reviewed paper that the Io plumes are comparable in form to a plasma gun. Similar filamentary plasma discharges are seen on the Saturnian moon Enceladus, though again, planetary scientists can only apply theories of cryovolcanism. But for several years, astronomers have recognized the electric current systems connecting Saturn and Jupiter to their respective moons, though they still imagine volcanism producing the detected charged particles. The electric universe is a connected universe, and the braided filamentary structures we see throughout our solar system, jetting from planetary surfaces, on the surface of the Sun, and in the plasma structures surrounding comets, as seen in this NASA infrared image of Comet Holmes, all attest to the electrical circuitry that governs our celestial neighborhood. We turn our attention now outside of our solar system to our galaxy's interstellar medium, and the extraordinary role that plasma filaments play in the formation of stars. A key prediction of the electric universe theory was outlined in the 2005 monograph, The Electric Universe, by Wal Thornhill and David Talbot. They wrote, plasma physicists argue that stars are formed by an electromagnetic pinch effect on widely dispersed gas and dust. The pinch is created by the magnetic force between parallel current filaments that are part of the huge electric currents flowing inside a galaxy. In 2015, this prediction was affirmed by data from the Herschel Space Telescope, which imaged in unprecedented detail networks of filaments throughout the Milky Way. A phys.org report on the observations states, ESA's Herschel Space Observatory has been a true game-changer. One of the key aspects that emerged from these observations is the presence of a filamentary network nearly everywhere in our galaxy's interstellar medium. The picture that is emerging is that these structures are closely linked to the formation of stars. The principal investigator of the survey stated, the greatest surprise was the ubiquity of the filaments in these nearby clouds and their intimate connection with star formation. But there is more. These observations revealed that filaments, which may extend to several light years in length, appear to have a universal width of about 1/3 of a light year. This suggests that something fundamental is lurking underneath. Of course, the fundamental thing lurking underneath the stupendous filaments is electricity. The universal width of the filaments that Herschel observed is not coincidental. On Earth, lightning bolts of constant width are sometimes observed to stretch for miles. Unfortunately, standard astronomy still holds to the pre-space age notion of an electrically sterile universe, and thus, the researchers attempt to explain the filamentary networks as follows. Turbulent motions of the interstellar gas and dust create an intricate web of filamentary structures. However, from the electric universe viewpoint, it is paramount that the most prominent filaments are seen drawing matter from a network of smaller filaments. Smaller coronal filaments are also characteristic of electric discharges in plasma. Other filamentary structures throughout the Milky Way attest to the spectacular electromagnetic energies that in fact organize and drive all galaxies. Near the center of our galaxy is a structure called the Galactic Center Radio Arc, a long-standing source of mystery for astronomers. The long parallel rays that shoot straight out from the galactic plane are described in an astronomy picture of the day as follows. The radio arc is connected to the galactic center by strange curving filaments known as the arches. The bright radio structure at the bottom right likely surrounds a black hole at the galactic center and is known as Sagittarius A. One origin hypothesis holds that the radio arc and the arches have their geometry because they contain hot plasma flowing along lines of constant magnetic field. Recent images from the Chandra X-ray Observatory appear to show this plasma colliding with a nearby cloud of cold gas. But plasma cosmology recognizes the dynamic behaviors of electric currents flowing through conductive plasma. What standard astronomy describes as, quote, long parallel rays, plasma physicists recognize as spiraling pairs of magnetic, field-aligned Birkeland currents. The so-called strange curving filaments are Birkeland currents feeding electrical power into the galactic center. In plasma cosmology, it is not a black hole, but a plasmoid that is responsible for the tremendous concentration of energies and therefore mass at the centers of galaxies. As we look at an even greater scale, we see affirmation of the underlying concept of the electric universe that, quote, there are no islands in space. Earlier this year, researchers publishing in the monthly notices of the Royal Astronomical Society reported the first ever measurement of the, quote, magnetic bridge linking the Milky Way's two nearest galaxies. Known as the Magellanic Bridge, the unimaginably vast filament stretches for approximately 75,000 light-years, connecting the large and small Magellanic Clouds. One of the researchers says of the findings, not only are entire galaxies magnetic, but the faint, delicate threads joining galaxies are magnetic too. Everywhere we look in the sky, we find magnetism. The lead researcher of the study stated, in general, we don't know how such vast magnetic fields are generated, nor how these large-scale magnetic fields affect galaxy formation and evolution. Understanding the role that magnetic fields play in the evolution of galaxies and their environment is a fundamental question in astronomy that remains to be answered. But as we explained in the first episode of this series, magnetism in space will always remain mysterious unless and until astronomers recognize the electric currents required to induce and sustain the magnetic fields. In fact, at the galactic scale, some of the world's most distinguished plasma physicists have provided experimental proof that resolves the, quote, mysteries, both of the motions of galaxies and their magnetic fields. Plasma experiments show that rotation is a natural function of interacting electric currents in plasma. A good example is the ubiquitous spiral galaxy, a predictable configuration of a cosmic scale discharge. Computer models of two current filaments interacting in a plasma have reproduced fine details of spiral galaxies, with no need for the influence of hypothetical dark matter. Consider the comparison of the images on your screen. On the top is a picture of the spiral galaxy M81, as imaged by NASA's Spitzer Space Telescope. Beneath are snapshots from a computer simulation by plasma scientist Dr. Anthony Peratt, illustrating the evolution of galactic structures under the influence of electric currents. Through the electromagnetic pinch effect, parallel currents converge to produce spiraling structures. Peratt was a protege of the Nobel Prize winner, plasma physicist Hannes Alfvén, who stated of cosmic electrical activity, "Space is filled with a network of currents, which transfer energy and momentum over large or very large distances. The currents often pinch to filamentary or surface currents. The latter are likely to give space, as also interstellar and intergalactic space, a cellular structure." Indeed, in the 1920s, it was Irving Langmuir who was credited with having coined the term plasma to describe an ionized gas due to its seemingly lifelike properties reminiscent of blood plasma. The filamentary structures we see throughout the cosmos, in the spectacular threaded networks and nebulae, to the high-energy collimated jets, light years in length, shooting from so-called Herbig-Haro objects, to the stupendous cometary knots seen in planetary nebulae, to the cosmic web where galaxies, like stars in our Milky Way, line filaments of matter like pearls on a string. All testify to the electromagnetic force, exponentially more powerful than gravity, organizing matter at every scale. For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.